Welcome to this presentation on container selection, preparation, and installation. Today we're going to discuss the proper sizing of propane containers, how to prepare them for the installation, and certain guidelines that propane technicians must adhere to when doing a propane installation. My name is Chad Ackner. I'm the Technical Service Advisor for Dealers LP Equipment and the R.E. Michael Company. R.E. Michael has corporate headquarters located in Glen Burnie, Maryland, and Dealers LP Equipment has locations in Davenport, Iowa, Louisville, Kentucky, Hickory, North Carolina, Jackson, Mississippi, Dothan, Alabama, and also Memphis, Tennessee. Please understand that anything we discuss today should in no way be misconstrued to override any of your local applicable codes, any insurance requirements, or any of your company policies. What we discussed today with regard to any code-related issues are referenced from NFPA 54 and NFPA 58. All propane installations must comply with NFPA 54 and NFPA 58. Additionally, all installations must comply with the local authority having jurisdiction, which may be a local code enforcement agency or a fire marshal. Company policies must be followed at all times. Equally important is following the manufacturer's instructions. Often referenced in NFPA 54 and NFPA 58 is the requirement to follow the manufacturer's instructions when installing propane equipment. That's actually part of the code. Work must always be done safely, and equally as important, everything performed, all installation work, leak tests, pressure tests, etc., must be documented and retained. The breakdown of NFPA 54 and NFPA 58 is as follows. Essentially, NFPA 58 will cover everything from the container all the way up to the outlet of the delivery regulator, which could be an integral twin-stage regulator or a second-stage regulator. NFPA 54 covers everything from the outlet of that very same regulator inside the building. It is highly recommended that anyone sizing LP gas installations not only have a Rigo L545 LP gas serviceman's manual, but also download the free Rigo app on their smartphone. In that Rigo app is a copy of the L545 Blue Book. It is a PDF version. In addition to that, there are regulator sizing calculators and also line sizing calculators. Quality Steel has a valuable app as well and will help you to calculate vaporization capacities. It gives you container sizing and much more important information. Today we will be discussing container purging and methanol application, container selection, and also some installation distance requirement information. A big part of making sure that we have a successful and efficient propane installation is to make sure that the containers are prepared properly before they're installed. A critical part of that preparation includes purging the containers or making sure that all of the impurities like nitrogen or air or any sort of inert material are removed from the cylinder or the tank and replaced with propane vapor. This critical part of preparing that tank or those tanks will eliminate any excessive or artificial pressure buildup inside the tank. It will also make sure that we have the correct air and gas mixture to all of the appliances. Additionally, it'll prevent any containers from being filled slowly. It'll speed up that delivery process. because of the lower pressure inside the container, and it will also reduce the potential for any tanks connected to the contaminated cylinder from being contaminated or affected by transferring that product from one container to the other. It's important to point out that while we're talking about the importance of purging containers, getting all of those impurities or contaminants out, that most all new containers, and even containers that have been professionally recertified or refurbished, are shipped from the facility that they were built or repaired. They're shipped with a vacuum purge already on them. So many of the steps we're going to be talking about over the next few slides do not pertain necessarily to new containers. However, there is a chance, and we'll get into this a little bit later in the presentation, that even those newer tanks, those new tanks, will lose that vacuum purge over time, whether it's through shipping or whatever. So the ability to repurge that container, the ability to know how to do that is very important. I mentioned excessive pressure buildup can occur. Well, consider the fact that propane on any given day, depending on the outdoor temperature, can be at a varying pressure. The warmer it is outside, the higher the pressure is inside the container. For example, on a 100-degree day, the approximate vapor pressure inside of that container is almost 200 pounds. Well, if you consider the fact that atmosphere or air at atmospheric pressure is nearly 15 pounds, it's easy to see that combining those two pressures, atmosphere and also whatever the pressure of the propane itself is inside the container, can result in an unsafe working pressure. It's also important to make sure that we have all of the air or inert gas out of that container before propane is introduced into it, because we want to make sure that we have a proper air mixture to all of the appliances. Propane appliances are designed and built at the factory or at the assembly point to mix the air in with the propane vapor at the actual burner tip or at the point of combustion. So if we provide that appliance with a product that already has air in it, it will obviously result in a burner flame or a burner tip lifting or becoming too lean to burn properly. Failing to purge containers can also lead to slow filling of those containers for the same reasons I mentioned a few slides back. When you're artificially increasing the pressure inside of a container with atmosphere, which again is nearly 15 psi, you are automatically creating a higher pressure inside that container for a delivery truck to attempt to fill into. So again, another reason that purging is just so important. And of course, when we have a multiple container installation and one of those containers was not properly purged and possibly has some impurities in it, of course, when those containers are connected together, those impurities will transfer from one tank to the other or migrate from one tank to the other, which will now create a situation where we have multiple tanks that are improperly purged. So just like that, with the proper purging of propane containers, you'll make sure that the appliances are operating properly. You'll make sure that the containers are filling faster. You'll reduce the risk of a premature pressure relief valve discharge. And you'll also eliminate the transfer of air or impurities from one container to the other. And of course, once this system is running efficiently and at peak performance, you're going to have happy customers as well. If a container's been open to atmosphere, there's a high likelihood that some impurities have entered the cylinder or the tank. Sometimes what happens is a cylinder will be left open. It will allow atmospheric pressure to enter inside the container, and then either the cylinder is simply left open or someone realizes the tank has been left open and turns it off. In those cases, sometimes the pressure will actually build back up. The point is, if a cylinder or a tank has been open to the atmosphere for any length of time, it's important to release the contaminated product inside the container to atmosphere and then begin a conventional purging process. Always make sure that any release of impurities or propane into the atmosphere is done in a safe, controlled manner in an approved location, such as a bulk plant or a different approved location for this process. It's important that when we do perform a conventional container purge that we always use propane vapor. We never want to use liquid propane. When liquid propane is used, as little as 50% of the air will be removed from a container during the process. The purging process is pretty straightforward. Again, using only propane vapor, we want to introduce approximately 15 psi into the container approximately 4 to 5 times. So in other words, we want to introduce the 15 psi, which basically is equal to 1 atmosphere. And we want to do that again 4 to 5 times. Each time we do this, we want to exhaust that 15 psi out into the atmosphere before the second 15 psi is introduced into the container. Probably the best way to do this is with an unloading adapter. We would take the unloading adapter and install it on the filler valve to open up the back check. Then we would take a 0 to 300 pound pressure gauge and install it through the POL connection on the service valve or multi-valve. Third, we would attach a vapor line to the container and pressurize the container from another source up to 15 psi, which again equals 1 atmosphere. The vapor would be introduced into the container through the 1.25" Acme connection on the vapor equalization connection. The next step would be to close the vapor inlet hose on the vapor equalization valve. Then vent the air and gas mixture to the atmosphere. And again, remember, this is something we're going to be doing 4 to 5 times. Incidentally, the product will be released to the atmosphere through the unloading adapter connection at the fill valve. After this procedure is done 4 to 5 times, the remaining or residual air left in the container is somewhere between 3 and 6%. Here's basically what happens when a conventional purge is done. After the first 15 psi purge, approximately 50% of the product remaining in the container is air. After the fourth purge, or the fourth introduction of 15 psi vapor, approximately 6% of the remaining product in the container is air. So you can see, if you look at the chart on page 12 of the Brigo Blue Book, the L545, that every time a purge is done, it cuts the remaining air inside the container down by approximately half. So the first purge left 50% air remaining in the container. The second purge left 25% air remaining in the container. The third purge left 12.5% air remaining in the container, and so on. Another thing to point out is how much product is used. And again, this is generally more of an old school way or an old school method to purge tanks, but there are some instances, even today, where this is required to be done. If a 1,000-gallon tank is purged properly, it'll consume approximately 18 gallons of propane to get that container properly purged. As I mentioned earlier, modern tanks all come from the factory with a negative pressure or a vacuum purge on them. They're all considered to be pre-purged containers from the manufacturer. Here, a vacuum pump is used to draw down or reduce the atmospheric pressure inside the container from 1 atmosphere, about 15 psi, to minus 27 inches water column. Another thing I mentioned earlier was to never remove the shrink wrap or the decals from any of the fittings on a vacuum purged container. It's a pretty simple process. The manufacturer pulls a vacuum on the container by putting an unloading adapter on the fill valve. Approximately halfway through drawing the vacuum or initializing the purge on that tank, the valve is shut off, the fill adapter is removed from the fill valve, and the remaining portion of the vacuum or drawdown is pulled through the POL connection on the multivalve. This is done because if all of the vacuum was pulled through the fill valve, the issue would be upon removing the fill valve adapter from the fill valve. And if the negative vapor pressure on the container were at full capacity, minus 27 inches water column, both checks inside the fill valve would be drawn open to pull atmosphere into the container, which is what we're trying to avoid. By pulling half down through the fill valve, we're doing it in an efficient manner and then finishing up that vacuum purge through the POL connection. And doing so will allow us to control with the service valve how much product passes into or out of that valve. With most all new containers being shipped from the manufacturer with a vacuum purge on them, and also reconditioned or refurbished containers being shipped from the refurbishing facility with vacuum purges on them, it's important to point out the 3 basic steps or 3 basic rules that we suggest be followed to make sure that that vacuum is not lost before placing those containers into service. When receiving pre-purged containers, rule number 1 would be to carefully remove the plastic shrink wrap and any stickers or decals placed on the fill valve and also the multivalve from the factory. Additionally, the 1¼ Acme cap and the 3/4 Acme cap must remain tight and not be removed. The service valve and the spitter valve also must remain tight and not be opened up. Failing to do any of these steps may result in the vacuum purge on the container being lost. So what happens if a vacuum purge container is received, but it's lost its vacuum, it's lost its purge? Well, in that case, that tank or that container must be purged the conventional way. Basically, what this means is introducing 15 psi of propane vapor into the container and then releasing it into the atmosphere. This is required to be done 4 to 5 times to remove any residual impurities or air from the container and place it into the atmosphere. It's often asked, how can you tell if the container has lost its vacuum purge? Well, you can tell because at the beginning of the next step, which is rule 2, it's required to introduce methanol into the container. And we do that by using the vacuum on the tank to draw that methanol in to treat the inside of that tank properly for moisture. If the container does not draw the methanol into it, using the method that we're going to speak about in a few moments, then that's a good indication that that container has lost its vacuum purge. It's important to point out that the number of containers that lose their vacuum purge between the time they leave the manufacturing facility and the time they're prepared for service, prepared to go out into the field, is very small. But it's worth noting what the proper procedures would be if that does take place. Rule number 2, again, is to begin to introduce methanol into the container. On page 9 of the Rigo L545, or that little blue book, it will detail how much methanol is required to be drawn into or injected into a container of a particular size. And again, if a container has a vacuum purge on it from the manufacturer, basically a measuring cup is filled with the appropriate amount of methanol. A rubber pigtail is connected to the POL connection on the multivalve and placed into the measuring cup. Then the service valve is simply opened up very slightly, which will in turn draw any methanol in the measuring cup into the container. It is important to make sure that that service valve is turned off before drawing any atmosphere or any surrounding air back into the cylinder or into the container. And the final rule, or rule 3, of properly purging or making sure the tanks are properly prepared for service is to introduce 15 psi into the container. So we're going from a vacuum or a negative pressure to 15 pounds positive pressure inside the container. Once that's done, caps can be removed and the container can have at that point liquid propane introduced into it. Two reasons why it's so important to introduce methanol into a new container is because over time, if water or moisture remains inside or on the inside walls of a container, it will lead to rust or it will cause oxides. It has been proven, and it has been well debated over the course of several decades, the fact that rust or oxides may affect the strength of the ethyl mercaptan that's injected into the propane at the terminal. So we want to prevent odor fade or any potential causes of odor fade from taking place to make sure that we minimize the risk of any rust or any oxides being created inside the container. Will go a long way into making sure that that happens. Another reason it's so important to neutralize the moisture is because that water in a tank or in a container will be withdrawn with the vapor into the pigtail, into the inlet nozzle of the regulator, and at certain temperatures or at certain BTU demands will cause the orifice that is built into the inlet nozzle to freeze over. And of course, when that orifice freezes over, it will essentially stop the flow of gas into the regulator. Always make sure 100% anhydrous methanol alcohol is used when treating containers. This will work the absolute best. Again, on page 9 of the Rigo L545, there is a chart that's listed showing the recommended amounts of methanol, or the minimum volume of methanol required for introduction into new containers, new tanks or cylinders. What about treating a tank that's already in service? Maybe a tank that's at a customer's location that's showing signs of having moisture, but obviously has a positive pressure on it because it's been in service for a number of years. Well, in those cases, you can use a methanol injector, which will do basically the same thing that drawing the methanol in does with the vacuum, but it will force with the hand pump the liquid methanol into the tank through the POL connection on the service valve. Just another way to be able to treat a container that's already in service. Sizing a propane tank is very important. Oversizing a tank will not hurt or affect the performance, but it can be impractical and also can be very costly to do so. Additionally, there may not be enough property or land available for a larger container to be placed on site. The real problem, however, is when a tank is undersized. When you undersize a propane tank for an installation, there are a few things that are guaranteed. The first thing is increased delivery costs, because the amount of times per year or per quarter that that location is required to be topped off is increased, therefore increasing your delivery costs. But the most important thing really with undersizing a container and the negative effect it can have is that it will not or may not vaporize enough BTUs or vaporize enough product to support the installation. Again, going back to the wetted surface inside the tank, the smaller the tank, the less amount of wetted surface where that liquid propane is touching or coming into contact with the sidewalls of the tank, which will almost guarantee a vaporization problem. And speaking of vaporization and a tank being sized properly to supply the BTU load, what's going on here? This is something we often see in installations where the tank is undersized. The tank will actually not be able to provide enough BTUs and not be able to vaporize enough liquid to supply the demand. Remember, the wetted surface, or the area where the liquid propane is touching the sides of the tank inside, will result in the tank's ability to efficiently vaporize that liquid. The more wetted surface, the better that tank will vaporize based on the BTU demand that's being placed on it. Propane will auto-refrigerate. Liquid will chill or cool if the propane liquid inside that container is attempting to vaporize or boil off at a rate higher than what that tank is capable of allowing or producing. In turn, any moisture that's on the outside of that container, on the outside of where that liquid is in contact with the steel of the tank, will freeze. That cold temperature from the liquid chilling or refrigerating inside the tank will in turn freeze the moisture on the outside of the tank, which will result in that frosting effect that you're seeing in the image on this slide. Propane providers will also have to determine what percentage to refill the tanks in the field. The chart on the screen shows a 1,000 gallon tank in temperatures of minus 15 degrees Fahrenheit, 0 degrees Fahrenheit, and 20 degrees Fahrenheit. Notice that the warmer the temperature is, and the more liquid volume that is inside the tank, the higher the BTU capacity or vaporization rate of that tank is. There's a direct relationship between amount of liquid inside the tank, in other words, again, wetted surface, and also the outdoor or ambient temperature. The higher the temperature outdoors and the more liquid volume or wetted surface inside the container, the better performance a container will have. Providers also need to determine what size tank is best. Maybe it's a 500 gallon tank. Maybe it's a 1,000 gallon tank. Is the customer going to add appliances in the future? Is this tank or is the tank location difficult to reach in the snow? Is there a bad driveway? all of these things come into play when determining what size tank to set for an installation. Before we begin our vaporization or tank sizing exercise, I want to point out the three main ingredients to determining proper tank sizing. The first thing we have to figure out is how many BTUs, what is the maximum amount of BTUs this installation will require? And also take into consideration what future appliances the homeowner may decide to add. Again, what percentage does the propane provider want to go to that location and refill that tank? It's inefficient to go when the tank is at 60 or 70%. But by the same token, you don't want to wait until the tank gets too low and risk that customer running out of product. The third step is to determine where this tank is located. Is it located in South Florida or is it located in Minnesota? The outdoor temperature or the coldest outdoor temperature that tank or that installation will be subjected to will also play a large role in determining what size tank to put in or to install at that location. So how do we size a large ASME storage container for an installation? It comes down to three measurements: the diameter listed as D, the length listed as L, and K, which is the lowest percentage of liquid that will be in that tank during normal operation. That percentage would be basically a target before refill. In other words, a tank would not get below, say, 20% or 30%. And each percentage, if you look at that chart on the screen, which, by the way, is on page 8 of the Rigo L545, shows a multiplier, or K, where it says K equals in the middle of the chart. K is basically representing a multiplier based on what that lowest percentage will be in that container. Essentially, we're taking D, the diameter of the tank, in inches, L, the length of the tank in inches, and we're multiplying those two numbers by whatever K represents. In other words, at 20%, the third multiplier would be 60. It's also important to point out that on all ASME containers, the diameter and the length in inches are listed on the data plate. Sizing an ASME propane container is pretty straightforward. Let's work through this one installation example. In this particular installation, we have a total BTU demand of 410,000. We have a propane provider that's decided to target refills at 20%. So that's the lowest this tank is anticipated to get. We're also in a region or a part of the country that experiences temperatures as low as 0 degrees Fahrenheit. That's our coldest expected winter temperature. So with all this information, what size container is required for this job? The first tank we're going to try to size for this particular job is going to be a 500-gallon above-ground tank. By looking at the data plate, we know that a 500-gallon above-ground tank has a 37-inch diameter and an overall length of 119 inches. So very simply, we take the diameter of 37 inches times the length of 119 inches times 60, which is, based on the chart, the multiplier for a 20% refill, or the lowest percentage that will ever be in that tank. If we multiply 37 by 119 by 60, we come up with 264,180 BTUs. So the question is, will one 500-gallon container work for this installation? The answer is no. Remember, our overall requirement is 410,000 BTUs, and that doesn't account for any potential future appliances being added to the system. So if a 500-gallon above-ground ASME tank won't work, let's try a 1,000-gallon above-ground tank. By looking at the data plate on a 1,000-gallon tank, it tells us that the overall diameter is 41 inches and the overall length is 192 inches. Now we take 41 inches times 192 inches times 60 for the multiplier of 20% as based on the chart. And we come up with 472,320 BTUs. So then the question becomes, will one 1,000-gallon tank work? The answer is yes. 472,000 BTUs exceeds the current BTU requirement. As we all know, different parts of the country or different regions experience different coldest winter temperatures. So on page 8 of the Rigo L545, there are also multipliers listed. If the coldest winter temperature your region experiences is minus 15 degrees Fahrenheit, you take that overall calculation that we just came up with in the previous slide and you multiply it by 0.25, or you take 25% of what that calculation was. And again, the calculation we did on the previous slide and also the slide before that for both the 500 and the 1,000-gallon tanks were based at a coldest winter temperature of 0 degrees Fahrenheit. If you're in a region that experiences the coldest temperature of 20 degrees, then you would multiply that overall number by 2. To show just how important a role outdoor temperature plays on inside or internal pressure and also BTU capacity, here are some examples of the differences of the same 1,000-gallon tank at 20% full. This one example is of that tank at 0 degrees Fahrenheit. Similar to the calculation we just made, it's the same tank. The BTU capacity of this 1,000-gallon tank at 0 degrees, 20% full, is 472,320 BTUs. If that outdoor temperature drops to minus 15 degrees Fahrenheit, that same tank at 20% full now will only supply a maximum of 118,080 BTUs. But if that tank is at 15 degrees above zero, that same tank is now capable of 826,560 BTUs, and that is with basically simply a 30-degree temperature swing between minus 15 degrees Fahrenheit to above 15 degrees Fahrenheit. So again, the same tank with different outdoor temperatures, we go from 118,080 BTUs at minus 15 degrees Fahrenheit to 472,320 BTUs capacity at 0 degrees Fahrenheit, all the way up to 826,560 BTUs at 15 degrees above zero. The same theory can be applied to vertical containers. In this example, we have a 120-gallon ASME container, which in theory is the same as a 420-pound DOT cylinder in regards to how much liquid volume it will hold at 80%. In this example, we have a total BTU load of 290,000 BTUs. We're again going to target a refill percentage of 20%. And in this region, the region that this container is located in, the coldest winter temperature is -5 degrees Fahrenheit. A typical 120-gallon vertical ASME tank is 30 inches in overall diameter and 54 inches in overall length, or in this case, height. Given those dimensions, and with the understanding that we're refilling at 20%, we're going to take 30 inches times 54 inches times 60, which again is the multiplier for a refill at 20%. If we multiply all three numbers together, we come up with 97,200 BTUs. Remember, our overall BTU requirement or BTU load for this installation is 290,000. So we have a total BTU capacity of this 120-gallon vertical tank at 97,200 BTUs. But remember, that calculation is based on the slide previously, which uses the chart in the Rigo L545 based at 0 degrees Fahrenheit. And remember, I said that this installation experiences coldest winter temperatures of -5 degrees Fahrenheit. So if you look at the chart, it'll tell you in front of you that the multiplier for a -5 degree Fahrenheit coldest winter temperature is 0.75, or basically 75% of what that container would provide at 0 degrees Fahrenheit. So if we take that number, we multiply it by 0.75, we come up with 72,900 BTUs for that container. But remember, our total BTU load is 290,000. So if I take the 72,900 BTU number, which is what the capacity of this tank is at -5 degrees Fahrenheit, and we divide that number into our total BTU load of 290,000 BTUs, that calculation comes up to 3.97. 120-gallon tank. So basically what that means is this installation has a requirement of 4 120-gallon containers to satisfy this BT requirement. Let's take a look at some of the separation requirements of exchange cylinders and also bulk cylinders, or cylinders that are filled on site from a delivery truck or a bobtail. Please note that tanks that are filled from a truck on site are required to be further away from external sources of ignition than exchange cylinders are, or cylinders that you would normally swap out, for example, at a hunting cabin or something like that. The reason for this is because when tanks are filled on site, product is released, even if it's a small amount, into the atmosphere. So therefore, they require, the code, NFPA 58, requires any container filled on site, in this example a DOT cylinder, to be a minimum of 10 feet away from a source of ignition. Exchange cylinders, on the other hand, are allowed to be within 5 feet of an external source of ignition because, again, there is no product release to the atmosphere when that cylinder is exchanged. This information, or these illustrations, are listed in NFPA 58 and also in the Rigo L545 Serviceman's Manual. The 2020 edition of NFPA 58 explains the steps to take when installing a group of containers with an aggregate capacity of less than 500 gallons. For example, in these two illustrations, two groupings of four 120-gallon tanks equaling 480 gallons of aggregate capacity in each group. Basically, what the code states is that if those groupings of containers are separated by a distance of 10 feet or greater, those groupings of cylinders can go directly next to the building. However, if you're in a situation where you cannot achieve a minimum of 10 feet separation between each grouping, and let's say the farthest away you can get between each grouping of four 120-gallon tanks is 8 feet, then essentially each grouping of containers at that point is required to be set off of the building a minimum of 25 feet. So essentially we go from allowing the groupings of containers to be directly up next to the building to requiring a 25-foot separation for those groupings of containers if those groupings cannot achieve a minimum of a 10-foot separation between the two. A lot of times you'll see this application in shopping centers or strip malls where they don't have a lot of space to put in a larger ASME horizontal tank. Here's a quick quiz. What's wrong with each of these installations? The answer is separation requirements. The installation on the left has a second stage regulator that is significantly closer to the window than 3 feet. That is the minimum distance that's required. The installation on the right has a 420-pound cylinder with a twin stage regulator installed, both of which are too close to the external source of ignition, which is the air conditioner. So there's always something to take out of the code handbook. When you are reviewing separation requirements or something similar to separation requirements, I often recommend getting the handbook version of that particular code book, not only because it explains to you what the actual code is, but it explains to you why that code came about, some of the history behind that code, and also a bit of a more in-depth explanation as to how that code was originated. Here's an example of a second stage regulator that was installed too close to a pool heater. In this case, this installation would have been fine if the vent to the second stage regulator was properly remoted away from the pool heater. Again, it's a minimum requirement of 5 feet from a regulator vent termination to a source of ignition. And again, yes, that includes pool heaters. And here's the same situation, but this time we're showing a second stage regulator being connected to a generator. Again, we are required to have a 5-foot separation between the regulator vent termination and a source of ignition. Again, a generator would be a source of ignition. Additionally, in this installation, the second stage regulator is not supported properly. Here's some great images about what not to do. The first image shows a 320-gallon ASME horizontal tank connected to a 420-pound DOT cylinder. Code states that the regulator has to be at the outlet of the manifold. In this case, each tank has its own regulator. Also pictured on the left, Polypipe is part of this installation, and polypipe is required to be installed below grade. The ultraviolet rays from the sun will have a devastating effect on the polyethylene material that piping is made from. Also, if you notice the larger image farther to the left, they were using, in this installation, an unapproved hose clamp type connection, all of which are out of code. And what are the issues here? In this installation, it appears to be a horizontal ASME tank with a small single-stage regulator connected to a fixed piping system. The code states that single-stage regulators can only be used in non-fixed piping systems of 100,000 BTUs or less. Also, it appears that someone tried to fix a small leak with electrical tape. Obviously, if you have a system where there is product leaking from the tank, the correct measures must be taken to get that leak fixed. Does this look like 10 feet separation between the container and both the house and the AC unit or the external source of ignition? Is this the correct piping material for a residential propane piping installation? Is the installation practice or the installation method correct per NFPA 54? There are situations in which a properly certified rubber hose for LP gas can be used. However, residential applications in particular where the exterior wall is penetrated and that hose enters the building is not an acceptable use of that product. Make sure to check out NFPA 54 for acceptable piping materials and joining methods. Also available in NFPA 58 and also the Rego L545 are ASME separation illustrations. In other words, both underground ASME containers and above ground ASME containers, and what their applicable distance requirements are. So let's see how good you are. How many code violations do you see in this installation? My guess is most everybody got these right. For years, there's been some confusion as to what an important building is. And what I mean is NFPA 58 often refers to an important building and what container separation requirements are from an important building. In the 2020 edition of NFPA 58, an important building was defined as a building that is considered not expendable in an exposure fire. For more information on what designates an important building in your area or your region, reach out to your local authority having jurisdiction for clarification. Are you aware that above ground ASME tanks are required to be on non-combustible supports if installed in permanent installations, whether that's masonry or another material? Always refer back to your local authority having jurisdiction for more clarification on this. Again, this is ASME containers above ground horizontal installed in permanent installations. It's equally important to note that containers should not be placed directly on the soil. Are you setting any containers not connected for use properly? If not, refer to section 6.3 in NFPA 58 for more details on how to properly and safely leave any containers not connected for use, whether it's at a job site or elsewhere. So what's wrong with this picture? Well, there's quite a few things wrong here, but if you look at the image, it's a 1,000-gallon refill station or fill station located under a canopy or under a rooftop that's been fully fenced in. What you can't see is that there's also a dumpster full of combustible materials next to the tank. All access paths to the tank are either locked or blocked off. This denies any access to the location from emergency personnel. Also, what happens if the relief valve goes off? Where is it going to go? It's going to immediately hit the ceiling. It's always important to make sure that any fill station that you're servicing or filling are up to code. Okay, now it's time for some Q&A. True or false? Temperature greatly affects pressure inside a container. The answer is true. Number 2, proper purging and air removal allows containers to fill blank. The answer is faster. True or false? Methanol should only be added in northern states. The answer is false. Number 4, vaporizations are blank at 20 degrees Fahrenheit than at 75 degrees Fahrenheit. The answer is lower. Number 5, true or false? In NFPA 58, containers may be set directly on the soil. The answer is false. Thank you for watching this presentation on container selection, preparation, and installation. Hopefully you've had some questions answered. Have a great day and be safe.